Hi, welcome to our talk on the Oracle Database Appliance Overview and Best Practices. My name is Carlos Ortiz, and my colleague, Paul Tsien. We're going to be presenting this to you. I'll do the first part on the overview, and Paul will tell you all about the best practices. Now, databases for most companies is the most critical IT service, and the reason is that it holds the information. It is fundamental to run the mission critical applications that keep your business running. Now, it also represents a big part of the IT budget in maintaining and buying all the databases. Therefore, why wouldn't you be running your database in the most optimized deployment? Let me show you what are the options on deployments. You can build your own, but this means that you're going to be putting together many components from different vendors. You're not going to get end-to-end support from them. And at the end of the day, it's not optimized for Oracle Database. You could also purchase just a converged or hyper-converged solution, but it is not fully integrated because the hardware and the software you're going to install do not communicate with each other. And at the end of the day, is also not optimized for Oracle Database. Now, if you're looking for a fully integrated software and hardware appliance, one that is purpose-built to give you the simplicity in the management of the Oracle Database, that is integrated with the public cloud, and you're going to get a single vendor to support the entire solution, and being optimized for Oracle Database, then you need an Oracle Engineer system. The Oracle Database Appliance is one of the engineered systems. And let me tell you what are the main values of the Oracle Database Appliance. So in this slide, you see 4 main principles. Okay, this is what customers asked us when we developed this product. Give us a product that is simple, not only from the time that I order, that I rack it, that I deploy it, but it will also be simple to allow me to manage the entire database lifecycle. Make it optimized. Hide the complexities within the software so I can just simply use a backup, a data guard, without having to know all the details. Now, make it affordable, right? Provide a low entry cost, but also give us the capacity to manage the licenses. We can start with small and then grow as our business needs grow. And make it end-to-end secure. Now, in the next slides, I'm going to mention each point to just give you more information. And we're going to start with simple. At the heart of the Oracle Database Appliance, we have this software that we call the Appliance Manager. It is a utility that allows you to manage the system and the database lifecycle, from the time that you deploy to you provision, patching. You can set up disaster recovery. You can run diagnostics. All of that is handled by our software. On the right-hand side of the slide, you can see a screenshot for the browser user interface. So you get this interface to just point and click and perform the functions. But if you like the CLI, command line interface, that is also provided, and also REST APIs. Now, one of the advantages of doing all this software integration is that if you need a system that runs your single instance databases or your rack databases, you can install it and have it ready to load data in 60 minutes or 90 minutes for the rack configuration. Now, on this slide here, I just want to highlight the simplicity compared to the other solutions. You have one system to manage. Many of our customers only have one database administrator just managing this appliance. You don't need many people. Every quarter, you get a patch that is going to patch every single component in the system. You don't need to contact multiple vendors to get the different patches. And at the end of the day, you're going to just perform minimal maintenance and support on this integrated appliance. Now, optimization. There are multiple areas in which we optimize it with the Oracle database. From the time that you select, I want to create a database, there are templates that are pre-built into the appliance. So you don't need to worry about many parameters. You just decide what version of the database you want. If you want a backup, RMAN can be complex. It is integrated in the Oracle Database Appliance, so you can just direct an internal backup, an external to an NFS appliance, or to the Oracle Object Store. And again, you don't need to know RMAN. Integrated data guard. With a single command, you can set up data guard between two Oracle Database Appliances to set up a disaster recovery environment. Also, if you want your applications to run close to the data, you can create virtual machines within our software. Or if you don't want the application and you just run the Oracle database in a virtual machine to manage your licenses, you can also do that. So these are just some of the examples of the optimizations that we've done, but there are more. Now, on affordable, customers didn't just want a low entry point, right? They were also very interested in reducing the operational expenses throughout the life cycle of the database with the simplicity and the automation that we provide. On this slide, on the upper portion, you can see on the left side, all the squares are filled up. Right? If you buy a non-Oracle system and you install the Oracle database, you have to license all the cores that are in the system. With the Oracle Database Appliance, you can go step by step. You can start with a minimum of 2 cores, and as your business needs increase, you can continue increasing licensing that. On the bottom part, right, it just shows that the integrated appliance will take just 60 minutes, 90 minutes for you to deploy your Oracle databases and immediately enjoy your time to value, your time to start your productivity. Now, secure. At Oracle, we control all the intellectual property. No one else does it. We don't outsource that. Okay? And our system is optimized, and we only give you the features that are necessary to perform the Oracle Database Appliance functions. We disable all the unnecessary services, and we conduct extensive security scans using industry-leading security scanners. And now the last point that I want to mention here is that if you install a standard Oracle Linux, there's over 5,000 RPMs that get installed. The Oracle Database Appliance only installs 1,132 in one of the latest versions, right? Because you don't need the rest, and we don't want any security holes in there. Now, I want to talk to you about innovation. On the left-hand side, you see many features that anyone can get with the Oracle Database Appliance. But on the right-hand side, those are the innovations that we've done with the Oracle Database Appliance, and you can only get it if you get an Oracle Database Appliance. I'll just mention a couple here that I haven't mentioned before, right? There is a built-in storage management and database clones that is integrated within the system. There is support for hybrid columnar compression. This is the only the Oracle engineer systems are the ones that support this, and the Oracle Database Appliance is one of them. Automated monitoring and phone home alerts, and as I mentioned before, capacity on demand licensing. Now, here's a view of the family. Right, this is the Oracle Database Appliance X9 that was just released this year. There are 3 models. 2 on the left run a single instance databases, and the one on the right-hand side can run single instance and rack databases. Now, you see the capabilities here in processors, in memory, and capacity. But on the y-axis, as you go from left to right, the performance is going to be higher. And on the x-axis, the capacity is going to be higher as well. And on this slide here, I just wanted to share with you what has been the roadmap since the first release, right? That was the version 1 in September 2011 to the X9 that was just released this year. And in these metrics here, you can see the tremendous performance increase in, uh, in the latest models. We every year or every generation, we look at the offerings from the industry and we provide the most cost-effective components that will give you an optimized performance as well. Now, there's thousands of critical deployments that we've installed since 2011. Everyone has a database, Oracle databases. You can see the example of the industries, financial, telecoms, healthcare, retail, etc. Right? Everyone installs it. And I wanted to share with you the typical use cases. The most typical is that customers want a rack solution, right? We call it rack in a box because in 90 minutes you can just have it running. Single instant is the second one. But customers are consolidating databases. They run a solution in a box. They install the application in the Oracle Database Appliance to run alongside the Oracle database, DevOps environments for test and dev, remote locations, departmental, and edge computing. Now, I want to leave you with this slide here. Additional information so you can go learn more. Right? Two things that I want to mention. Number one, the YouTube playlist. Take a look at it. We give you real demos of the appliance. And the last one that says Aura Simulator, go here. You can create a free Oracle Cloud account and install the simulator, run it so you can experience the software. And now I'm going to pass it on to my colleague, Paul Tsien. He's going to tell you everything about the Oracle Database Appliance best practices.
Thank you, Carlos. Welcome, everyone. I'm going to cover the Oracle Database Appliance or ODA best practices in the following areas: planning, development, management, high availability, patching, and monitoring and diagnostics. So let's look at planning best practice first. ODA planning best practice is really about understanding your workloads and come up with the optimal configuration for deployment. So the questions to ask are, do you need high availability? If you do you need real application cluster or rack 1, or single instance database failover? Do you need dedicated bare metal ODA to run database only for better performance? Or do you need flexibility of putting applications and databases in virtual machines or VM for better isolation and utilization? And of course, you need to understand, do you need large amount of storage or do you need better I/O performance? Some additional questions to ask are, do you know how many CPU cores and amount of memory you require for your total workloads? Can some of these workloads share CPU cores? And also, of course, you need to understand what type of network you have, how many network ports you need for your systems, and do you need virtualized network or VLAN? Or finally, do you need headroom for future expansion? So these are the questions that you need to ask to determine your optimal ODA configuration for deployment. So let's move on to the ODA deployment best practice. ODA deployment best practice is really about how do you set up ODA very quickly with minimum number of issues. So these are our recommendations. We want you to go through ODA checklists in the documentation first and collect all the information you need before deployment. And then we want you to download all the ODA required files for deployment. Again, typically these are grid infrastructure or GI and database clone files, which are just binaries. And but it's nice to have them available before you start a deployment. And then of course, we also want you to run validation commands to make sure that the environment is ready for deployment. And then, of course, we recommend you to set up ASR for hardware monitoring for future hardware issues. Then we move on to ODA management best practice. And this is really about how do you set up a stable ODA environment that does not have too many issues. So these are our recommendations. Always use only ODA commands or browser user interface to perform management of your databases and VMs in the ODA. And also try not to modify any parameters or configuration files manually. And try not to install any unnecessary applications or RPMs. ODA has a feature called version lock built in to detect any potential RPM conflicts with the ODA RPMs. Next is to avoid any interactive shells in patching scripts. And of course, you need to track any customization you do with ODA because you may have to back them out before patching and then reapply them after patching. So these are the things you should keep in mind. And you follow these rules, your ODA environment should be very stable with minimum amount of problems that you may face. Next, let's look at ODA high availability best practice. This is also very important to our customers so that we want to make sure you experience minimal impact during planned or unplanned downtime. So these are the recommendations. Always try to follow Oracle maximum availability architecture best practices. Typically, this involves RAC and DataGuard. And always use the latest version of the ODA tech briefs that will have the most up-to-date information if you're following the steps in those tech briefs. And then always use triple mirroring for your production databases and have the most recent backup available for availability reasons. Then we want you to use ODA HA to protect your database, application, and system locally so that you can fail over if anything happened to one node. And then we also recommend you to protect your database, application, and system remotely through a second ODA so that, if there's any natural disasters in one data center, you always have a backup somewhere remotely. Then let's move on to ODA patching best practice. This is probably the biggest challenge for most database administrators and system administrators. How do you keep a complex IT infrastructure up to date and running optimally all the time? So what we recommend is that with ODA, always develop a patching strategy. How many ODAs do you have? How frequently do you need to update the ODA? And then how much downtime you can afford? So the next recommendation is that always test the patches on a test ODA before you test on a production ODA. So this way you can resolve any issues you run into with a test ODA rather than have an impact to the production ODA. And then of course you want to do some validations after you have patched the system. Now, Oracle release ODA software every quarter, but we recommend our customers to always stay within the most recent 4 releases because those are the ones that have been tested by Oracle QA testing group. So you can ensure that those releases patching will have the least amount of issue or potential issues. And of course, always review the recommended and minimum ODA software release for your ODA, and then also check the support notes on database release status as well, because over time, older version of a database support actually goes away. So you want to make sure you are staying the most recent database releases as well. The ODA patching involves 4 steps, and we'll go through each of the steps in details. So they involve patching preparation, server and storage patching, database patching, and then database system or database in KVM and application KVM patching. In terms of preparing for ODA patching, we want you to review the latest release notes and the known issues and workaround in the ODA documentation. And then also review patching steps in ODA documentation. And of course, download and update the repository with ODA software before you actually start the patching process. And then, of course, run the pre-check before you patch the server, and then install the latest version of the ODA backup and recovery or ODA BR utility on all the nodes. And we have a MOS node that documents how to run this utility. So the next step is to start out with a server and storage patching. So this is really about infrastructure patching that patches firmware, operating system, and GI or grid infrastructure. So what we want you to do is always stay on the latest ODA software release that will have the latest bug fixes and all the new features. So the step to do this are to take a logical volume of the snapshot with the ODA BR tools on both nodes. So this takes a copy of the system or boot disk image. In case your patching has issues, then you can always revert back to your pre-patch state and continue operation rather than being impacted if anything happens during patching. Then the next step, of course, is to update the server components. We want you to do it with the rolling option to minimize downtime. And then following that, we want you to patch the storage components, again, with rolling option so that to minimize downtime. So after you patch the server and storage, the next thing is you want to patch the database or upgrade the database. Now, this is also important to always have the latest release of the database RUs or release updates because it has all the new features and bug fixes and security fixes. So for database patching process is that, again, you run the pre-patch report and fix any issues identified, and then you update the database home. By doing so, you actually patch the database. For database upgrade, the steps are a little different. You first have to download the required database clone and then update the repository, and then you have to create a new database home, and then you can upgrade the database. So again, all these steps are in the documentation, so please review them before you actually do them. And after that, the next step is really patching database system or database in KVM and application KVM. This is in a virtualized environment. So what you do is you must take a backup of the DB system using ACFS snapshot technology. So in case anything goes wrong, so you have a backup of the DB system. Now, in order to patch the database in the DB system, you actually have to go into the virtual machine and then use the ODA commands and browser user interface to patch or upgrade the database like you did in the bare metal system. And that's how you do it in a DB system. And then the next thing is the application KVM, which is a black box from ODA perspective. So therefore, to patch the operating system and the application in the application KVM, you must do them manually by logging into those KVMs. And our final best practice is monitoring and diagnostics best practices. This really helps you to monitor and prevent any component failure or even software failures. So we recommend you to always deploy ASR to detect hardware issues, and then also use ODA plugin to monitor the ODA itself. And then in case anything goes wrong, make sure you collect all the relevant information so that you can upload this to Oracle support. And of course, always file an SR you run into any issue. So this really concludes the 6 areas of best practices for ODA. And at this point, this concludes our presentation on the Oracle Database Appliance overview and best practices. Thank you.